about our unit circle. It is something that you should probably have memorized, and so I'm going to teach you how I memorize it. First of all, I'm going to talk degrees. So again, if you think about splitting up a circle into 90-degree angles, we have 0 degrees, 90 degrees, 180, 270, and 360. Now, what would be the easiest from here is to divide these again in half. So now I'm going 45 degrees, another 45 degrees brings you to 90, another 45 degrees is 135 degrees, another 45, another 45 brings us to 225, another 45, another 45 is at 315, and back to 360. So that should be pretty easy and make sense. The other way that the unit circle is broken up is by 30 degrees. So 30 degrees plus another 30 degrees plus another 30 degrees and another and another and another, all the way around the unit circle. Sometimes I hit 30 degrees that is already on the unit circle, like the 270, but sometimes I have to create another line. And that brings us all the way back to 360 degrees. Okay? Now, we don't always use degrees, but we also use radians. So let's talk about radians. Again, let's start with the simple one. We have 0 pi, half a pi, pi, 3/2 of a pi, and 2 pi. Now, just like the next ones that we did, we broke up in half, or 45-degree angles. Let's think about what's half of a half. Well, half of a half is a fourth. So we're going to be splitting the 45 degrees up by fourths. So 1/4, 2/4, which reduces to a half, 3/4, 4/4, which is 1 pi, 5/4, 6/4, which reduces to 3 pi over 2, 7/4, and 8/4, which is 2 pi. Now, the other way that we're going to split it up is just like we did the 30, 60 degrees all the way around. And this time, this is dividing things up into 6. So this is 1/6, 2/6, but what does 2/6 reduce to? 1/3. So we want it 1/3. 3/6, which is the same as a half. 4/6, but remember 4/6 reduces to 2/3. 5/6, 6/6, 7/6, 8/6, but 8/6 reduces to 4 pi over 3. 9/6, which is the same as 3 pi over 2. 10/6, but that is the same as 5 pi over 3. 11/6, and 12/6, which is the same as 2 pi. So that is the way that we're going to memorize or do this. I bet you'd be able to do a lot of that already on your own. Now, there's another way that this is labeled, and this is by coordinates. If you think about this right here being 0, 0, that means this point out here is 1, 0. This point up here is 0, 1. This point over here is -1, 0. And this point down here is 0, negative 1. Those again should be pretty easy. Now, the rest of the unit circle is a combination of a couple different things. If we had a 45-degree angle, 45-degree triangle, this is a 90-degree triangle, that means this in here is 45. And what do we know about 45, 45, 90? That the legs are exactly the same distance. So x is the same distance as y. And if we were to solve this right now and take the square root, if our radius was 1, this would give us the square root of 2 over 2 for both x and y. So if that's the case, this is also another 45, 45, 90. So that means this is the square root of 2 over 2 and the square root of 2 over 2 for x and y. However, when we're in quadrant 2, when we go left, our x value becomes negative. Here is another 45, 45-degree triangle in quadrant 3. Again, when we go left, it's negative, and now when we go down, x is negative, or y is negative. And last but not least, here's our last 45, 45, 90-degree triangle when x is positive and y is negative. Now, the last triangles are combinations of 30, 60, 90-degree triangles. It just depends on where the triangle lies and which part is longer than the other. So if you look here, this is a 30, 60, 90-degree triangle. X is much longer than y. So we have x is the square root of 3 over 2, where y is a half. Okay? But when I go to this triangle right here, this is a 60, 30, 90, and this time x is shorter and y is longer, so these values right here are just going to flip-flop. Y is longer, so it gets the longer value. And by the way, the square root of 3 divided by 2 is about 0.9, so that's why it's a little bit longer. So now look at this triangle right here at 120. Is x longer or is y longer? Well, y is longer, so y gets the longer of the two values. And be careful, we're going left, so it's negative. When I get to this triangle right here, x is longer than y, so x is negative square root of 3 over 2. Y is the shorter value. Same thing here. This is the exact same triangle that I just did here. However, this time x and y are both negative because it's quadrant 3. Which triangle am I drawing right here? X is short, y is long. X is short, y is long. However, in quadrant 3, both x and y are negative. Same triangle here. X is short, y is long, but y is only negative. And here I have a short, long x, short y, long x, short y, but y is negative. Now, I know that that's a lot of information. I do have a unit circle for you, but it's important to see where this all comes from. Now, what similarities do you see? Well, if you look here, do you see how these 30 degree and 330 have the same? There's just x's and y's are negative or positive. And they are exactly the same when they are reflected over here. The only difference is the negatives and the positives. So look at here. Do you see these triangles and how they're reflected in here? And now what do you notice? These x and y's are the same as these x and y's. So that also maybe can help you a little bit on your memorizing. Now, one quick thing I want to remind you of is just our coordinates in our quadrants. Remember, in quadrant 1, x is positive and y is positive. In quadrant 2, we're moving to the left, so x is negative, but we're moving up, so y is positive. In quadrant 3, we're moving to the left and down, so x is negative and y is negative. And in quadrant 4, we're moving to the right and down, so x is positive, but y is negative. And that's where I was getting all of those positives and negatives also. So we're going to get going on the unit circle here over the next few days, and this at least gives you an opportunity to do some learning and some memorizing with it.